In this video, I'm going to show you how to create the engineering drawing for part number 2 on your IME 144 SolidWorks Intro to Modeling and Drawing assignment. So we're going to go ahead and create this drawing that you see right here on the screen. To do so, we're first going to go to SolidWorks. We're going to go File, New, and we're going to select Drawing. Your first step when creating an engineering drawing is to select your title block template. Now, I've provided a title block template for you to download up on Polylearn, and the previous video, drawing number 1, shows you how to insert it as one of the standard sheets that you can pick by default. So I'm going to select the IME 144 SolidWorks drawing template, and press OK. Now, by default, the Model View tool shows up and allows me to hit Browse and select the appropriate part file I want to make the engineering drawing with. However, I'm going to go ahead and press X right now and click on View Layout and show you that there's Standard 3 View and Model View. The previous video showed you Model View. I'm going to now show you Standard View. So I'm going to click on Standard View. I'm going to hit Browse. Hold on, I guess my computer's a little slow. I'm going to hit Browse, and I'm going to go find where I've saved my part model last, hence Part 2 video example. When I press Open, it automatically creates a 3-view drawing of my part, like you'll see in the drawing provided. Now let's go back to SolidWorks, and let's look at a few things. If you notice, there's lines where the tangent edges of the fillets terminate. This is not normally shown on an engineering drawing, so I'm going to go ahead and remove these from these different drawing views. So if I right-click on the drawing view, you'll see it says Tangent Edge. You can make the tangent edges visible, which in some cases you want to, in other cases you don't. In this case, we're going to go ahead and pick Tangent Edges Removed. That takes away the tangent edges from all the curves. So I'll do that on all 3 drawing views. Now, moving back to the drawing, you'll see it looks a lot like the drawing views provided. However, we're missing hidden lines in our drawing view. So if I go back to SolidWorks, I can easily click on the drawing view and select over in the menu tree over here on the left, Hidden Lines Visible, and it places the hidden lines on the part. Now, you'll notice if I go back to the drawing provided, we have a pictorial view or an isometric drawing of the part in the upper right corner. The Standard 3 View option does not create a pictorial drawing. So what we're going to do is we're going to use the Projected View button. We're going to click on the main view, the front view, and drag out diagonally in order to create a projected view or an isometric view based off of the front view. Now, I want to show you real quickly, you can use Projected View, click on any view to get a projected image based off the different ways you drag your mouse. Just wanted to point that out. I'm going to press Escape in that one. And now as we look at the isometric view up here, or the pictorial view, we don't want to show hidden lines. It kind of easily confuses people when you have too many hidden lines. So what I'm going to do is I'm going to click on the drawing view, and up here at the top of the screen I'm going to select just visible lines only. Another thing I'm going to do is I'm going to remove the tangent edges visible. So I'm going to right click on it, select Tangent Edge Removed. Now, if we look back at the drawing example provided, you'll see I kept the tangent edges up here in the pictorial view. However, they're not needed, so I'm going to move back here and I'll actually keep them on so it matches the drawing view like I've assigned. So we'll go back to Visible. Okay, now we're ready to make these orthographic projections into an engineering drawing by adding dimensions. So looking at the drawing view, we're going to go through and we're going to create a couple of different types of dimensions, a little bit different than what we did from part 1. We're going to create an angle dimension. We're also going to create a chamfer dimension. So I'm going to start off now by creating the angle dimension. To do that, I'm going to click on Annotation, Smart Dimension. I'm going to click that line to that line and drag my angle up. Now, notice the drafting standard is set in ISO because the angle doesn't come between the dimension line. So what I'm going to do is I'm going to go to my options. I'm going to select Document Properties. I'm going to go to ISO real quick, and then we'll go back to Options, Document Properties, and ANSI. Press OK. You'll see the dimension becomes horizontal and goes in between the dimension lines. Another thing it didn't do was make a small gap between the visible line and the extension line off the angle. So if I click on the extension line and I drag my extension line upwards, I can actually create that visible gap. See, I'm going to drag it down so it has a slight gap in between there. Next, I want to go ahead and spread out or move the right view over slightly. So I just simply click on the view and drag, holding my left mouse button down. The next dimension I want to place is my chamfer dimension. So underneath this flyout menu for Smart Dimension, you'll see there's a chamfer dimension button. If I click on that, the first selection I select is the hypotenuse for the chamfer. Then I pick one of the legs and I drag it out, and it creates the 0.05 by 45 degree chamfer callout. Now, notice there's just one chamfer on the bottom of the part, so I don't have to type in 4 by or 2 by. It's the only chamfer that's actually on this part. Okay, now we're ready to go ahead and create all the different size and location dimensions for the other linear distances on this part. So looking back at the engineering drawing provided, I have to go ahead and create the 2-inch and the 2-inch dimension from the left corner of the part. So what I'm going to do is I'm going to go back to SolidWorks. I'm going to select Smart Dimension, and I'm going to dimension from this edge to the center mark, dragging downwards. The next dimension I'm going to create is from the bottom to the center mark, dragging over, and clicking my mouse button. Now, one thing that's missing is the radius up here. So I click on the radius, drag it upwards to 1.25. So you'll see we got the radius call out, we have the location. Now we just need the hole call out, diameter of 1.0. Moving back to the engineering drawing that we're referencing, you'll see that we need to go ahead and create a 2 by on our 1-inch through hole. Now, notice if I go back here, I created the 1-inch dimension on this view. If I wanted to change that, I could actually click on the dimension, delete it, and then come up to the top hole and click on it, drag it down, and have 1-inch diameter. Now, I need a prefix and a suffix on this dimension. To do so, if you click on the dimension and highlight it, you'll see over in the dimension text we have the diameter symbol and then the dimension that it pertains to the model, the solid part model. So I want to go ahead and click before the MODDIAM symbols and type in 2 uppercase X space. That means there's going to be 2 holes at 1 inch, and I'm going to go ahead and type in THRU. Remember, the through hole is optional because if you don't have a depth specified, you assume that it's through. Although you might see some legacy drawings that still have through, hence we're still showing you the actual through call out on the hole. Now, another dimension that's missing is right down here, the thickness of the part. So if I go from that edge to that edge and drag outwards, you'll see I have that 1-inch thickness. When I press escape, in my dimensioning tool, I'm able to then click on other dimensions to move them out of the way so they're not too close. So you'll see you want to make a nice legible drawing and not overly crowd the dimensions. So I believe this front view, if I move it over a little bit, is fully defined. Going back to the engineering drawing that was provided for you, you'll see we have the radius, we have the location of the radii, we have the angle, we have the thickness of the flange, and then the chamfer size. So what we're going to want to do next is go ahead and create the center lines for the right view and the top view, and then finish dimensioning those views. So moving back to SolidWorks, you'll see that we have a centerline tool. Remember, you could automatically insert center lines by selecting Auto Insert and select View. Then you just click on the view and it actually creates the center lines. But notice it created the center lines for the radii, which we don't really want. So I'm going to go ahead and press Ctrl-Z. You could actually delete them one by one, but I'm going to use the centerline tool and simply select the different lines that I want to create a center line between. So if I want one there, I want one there, and it creates the center lines for me. Again, I pick one line, another line, and it'll create the center lines for me. Now in this view, the center line should extend past the visible lines. So if I click on the center line and drag it downwards, I can actually extend it out past. You want them to extend out equally on both sides. Okay. At this point, we're ready to start dimensioning. So if I move over here to my right view, I can go ahead and grab my Smart Dimension tool, grab up, drag over, click on the line, drag over, and now I have 2 dimensions, but looking at the engineering drawing, there are actually 3 decimal places. So moving back to SolidWorks, you can change the precision of your dimension by simply clicking on the dimension and going right down here to the precision and selecting the amount of decimal places you want it to grab from the solid model. So we want 3. At this point, we're going to go ahead and dimension this upper view. To do that, you'll notice back in SolidWorks that we have radii. So we're going to go ahead and dimension the radii and then the locations of the hole, the overall width, and then the length of the part right there. I guess width and then length. So moving back to SolidWorks, if I want to create a radius dimension, I can click on the radius, drag upwards, and you'll see that I have a radius of 0.5. Well, I know there's 4 of those radii, and I'm going to go ahead and click on 4 pi with a space bar. So now you'll see I've got 4 radii by 0.5, and I'm going to go ahead and do the overall thickness, or the width. So I'm going to go from here to here, drag down, and now I'm going to click on the extension lines and drag them down slightly. So there's a little bit more of a visible gap. You see, it put a very small visible gap. Excellent. This one I'm going to adjust so it's equal with the other one. There we go. Well, a little bit more. Well, we're pretty close there. Obsessive compulsive issues. Okay, now that we've got everything defined other than the actual location of this hole, let's do that. So to locate that hole and to go ahead and give the overall depth of the part, I'm going to select baseline dimensioning. My first point on my baseline dimension is going to be here. My next point's my mark. Then last but not least, I want to pick the upper portion of that. And remember, in baseline dimensioning, it's the first line that you pick as your baseline. After that, it'll go ahead and just allow you to quickly pick other dimensions. Now again, it didn't leave a large visible gap on the radius, so I'm going to go ahead and drag those out ever so slightly to leave a little bit more of a gap than the default value. It cleans up the drawing, especially when you make it into a PDF. See, there's 2 lines there, so I had to do it twice. Okay, the last dimension we need to go ahead and create It's the dimension from the edge to the center of the circle. To do that, I'm going to hit Smart Dimension, and I'm going to go from that edge to the center mark and drag it out. When I zoom in, you'll see I'm going to drag the dimension line down ever so slightly, leave a little bit more of a gap. So looking at this drawing, we're going to go back to the example and see if we missed anything. Now I'm going to show you how to change up the way the dimensions are located a little bit and how to clean up dimensions. So moving back to SolidWorks, if I wanted to go ahead and make this be outside the dimension lines, I could drag it outside, and I could also change the distance ever so slightly for the horizontal line. If I wanted to flip it to the other side, you could click on the little dot right here, and it goes back and forth. So wherever you basically move it, it'll follow with you using the ANSI or ASME Y14.5 standards. So moving this in, you want to clean up your drawing, make sure there's not a lot of confusion with cluttered dimensions. Alright, the last step we're going to do is we're going to go ahead and fill out the material, the title, and the date before we print our drawing out to turn it in. One thing the title block actually did was, if you notice the scale down here, 1 to 2, well, my drawing scale is actually 1 to 2. You always want to double check that the scale is correct. Looking back at the drawing provided, it is a scale of 1 to 2. So we're good there. However, we need to insert a material. Looking back at the drawing, we have 1018 cold rolled steel. That's what CRS stands for, cold rolled steel. So to type that in, we simply go to our note tool, we click down in the material, we go 1018 space CRS. Now the date, we're going to go ahead and type in 09-23-19. And if you need to press escape to end the note tool, you can then click on the note, hold your mouse button down, and actually move the note or position it so it looks even in the title block. The last step is to go ahead and type in IME 144 SolidWorks Intro to M&D number 2. So I'll go ahead, click on the note tool, come down here, IME 144 Intro to SolidWorks M&D number 2. At this point, in order to end the note tool, I press escape and I press my space bar, and I'm going to hit zoom fit to go ahead and fit the drawing to my view. Looking at the drawing, we have all of the dimensions needed to manufacture this part shown, and we're ready to go ahead and save. So I can go File, Save As, and I save it wherever I save my part file. Finally, if I didn't have a computer that had SolidWorks on it hooked up to a printer, I could go File, Save As, and I could pick a PDF. Therefore, I could easily go print my PDF anywhere in the library or anywhere that a computer is hooked up to a printer. So hopefully you've enjoyed this tutorial and you've learned a little bit about engineering drawings. I'll see you in the next videos. Have a great day.